In this video, I'm going to show you how we can generate electricity using an AC generator. And I'm going to break it down as much as possible back to basic principles so that you can easily understand how power stations work, such as hydroelectric power stations, coal-fired power stations, nuclear power stations. If I turn on the magnetic field, we can see that the north end of the magnet would attract the south end of another magnet. You can see that because these compass lines around the side indicate the magnetic field. So north attracts south, and south attracts north, and north would actually repel north, and south would repel south. So here we've got our incredibly interesting permanent magnet again. Now moving my magnet around, you can see over here, and I'll drag it up to here, and you can see there's not really so much happening. But look what happens when I move the magnet over here. And I'll move it back again. When we move the magnet through the coil, we're actually inducing a voltage in the coil. In addition to this, we're actually inducing current flow because this is a closed circuit. We know that if I change the magnetic field very quickly, then I can induce more voltage than if I move the magnet very slowly. And hopefully if I turn the water on and I play the animation, we can see that the water is running, the water wheel is rotating, the magnet is rotating, and because the magnet is placed near our conductor coil, we're inducing a voltage in that conductor coil. But we can also strap our magnet to a wind turbine rotor and it will also spin continuously. Or perhaps we can strap it somehow to the shaft coming out of a steam turbine. That will also work. Or we'll take a diesel engine and connect it to a shaft on the diesel engine. All of these items that rotate our magnet are referred to as prime movers.